Alright makers, builders and engineers, Adam Savage here. Today we're diving into welding symbols, the universal language that connects the designer's brain to the welder's hands. On an engineering drawing, welding symbols are the most critical instructions you'll find. They tell you what kind of weld is needed, where it goes, and how it should be finished. It's a beautifully efficient system, packing tons of info into a tiny graphic. This isn't just about memorizing shapes, it's about understanding the logic behind them. These symbols are a powerful tool for communication, turning imagination into reality. Let's get started. Why all the symbols? Why not just write, put a 1/4 inch weld here? Simple efficiency and clarity. Imagine a complex drawing for a skyscraper or airplane wing. Writing out every weld instruction would be chaos. Symbols condense instructions into neat, compact graphics, saving space and reducing confusion. More importantly, they create a universal standard. A V-groove weld symbol means the same thing worldwide. This global consistency eliminates ambiguity and prevents dangerous misinterpretation. Welding symbols precisely indicate which side of the joint to weld. No room for doubt. This precision is the bedrock of good engineering, ensuring the welder executes the designer's intent exactly. It saves time, money, and materials, and most importantly, keeps structures safe. Adopting this symbolic language is a massive leap forward in communication. It's like using a chemical formula instead of a paragraph. Faster, clearer, and universally understood. Welding symbols are the elegant shorthand of fabrication. They ensure what's designed is what's built every time. Let's break down every welding symbol into its 3 core parts: reference line, arrow, and tail. The reference line is always horizontal, the foundation for all info. The arrow points to the exact joint needing the weld. Your X marks the spot. Placement matters symbol below the line means weld on the arrow side. Above means the other side. If you see symbols on both sides, weld both sides. The tail, a V shape at the end, is optional and holds special notes or process info. For example, GTAW in the tail specifies the welding process. No tail? The process is up to the welder or noted elsewhere. Think of the tail as the special instructions box. Master these 3 components, and you've learned the grammar of welding's language. Reference line, arrow, tail. Get these, and you're halfway there. Now let's learn the vocabulary. Now, let's fill in the structure with the most common weld symbols. The fillet weld, represented by a right-angled triangle, is the most common. It joins 2 surfaces at an angle, like a T-joint. Triangle below the line, weld on the arrow side. Above, other side. Groove welds join 2 pieces edge to edge. The symbol looks like a cross-section of the groove, V, U, J, or parallel lines. These symbols tell you how to prep the metal for deep, strong welds. Plug or slot welds use a rectangle, weld through a hole or slot to join overlapping plates. Spot welds, a circle, and seam welds, circle with lines, are common in sheet metal work. Surfacing welds, scalloped line, add material to a surface, not joining parts. Great for repairs or hard facing. These basic symbols, fillet, groove, plug, spot, surfacing, cover 90% of what you'll see. Learn these, and you'll read most welding instructions with confidence. Each symbol is a shortcut to a specific weld type. Recognize them, and you're well on your way. Let's add more detail. Engineers use supplementary symbols to add detail. The weld all-around symbol, a circle at the arrow reference line intersection, means weld the entire joint perimeter. The field weld symbol, a solid flag, means the weld must be done on site, not in the shop. Contour symbols specify the weld's final shape: flat, straight line, convex, upward curve, or concave, downward curve. These affect stress distribution and are critical for performance. Finish symbols. Letters like G, grinding, M, machining, or C, chipping, show how to achieve the final contour. For example, a flat line with a G above a fillet symbol means fillet weld, then grind flat. Supplementary symbols turn basic instructions into a detailed recipe. They add precision for high-performance welds. Let's see how dimensions fit in. Weld size is crucial. Dimensions are always part of the symbol. For fillet welds, the number to the left of the triangle is the leg length. For intermittent welds, numbers to the right indicate length and pitch, spacing. Groove welds may show depth to the left and root opening or angle inside the symbol. For example, 1/4 left of a triangle means 1/4 inch legs. 2/6 right of the symbol means 2-inch welds every 6 inches. Plug or slot welds use numbers for diameter or width, left, and spacing, right. The placement of numbers is systematic: size to the left, length, pitch to the right, angles, root openings inside. Once you know this logic, extracting info is quick and easy. Dimensions make the symbol a complete instruction. Practice reading them, and it becomes second nature. Now, let's see real examples. Let's apply what we've learned to real drawings. Example 1. T-joint. Arrow points to the corner, triangle below the line, 1/4 to the left. That means a 1/4 inch fillet weld on the arrow side. Example 2. Butt joint. V-groove symbol, 60 degree inside, 1/2 to the left. Weld both sides. Example 3. Surfacing weld on a shaft. Scallop symbol, 1/8 to the left, EH14 in the tail. These symbols show location, type, size, and special instructions. Practice decoding, and soon you'll visualize the whole process. Let's wrap up with a cheat sheet. Here's your quick reference checklist for any welding symbol. Find the reference line and arrow. The arrow points to the joint. Arrow side versus other side symbol below the line means arrow side, above means opposite. Check for a tail. Read any special notes inside. Identify the weld type triangle, fillet, VU parallel lines, groove, circle, spot, scalloped, surfacing. Numbers to the left equals size, right equals length, pitch, inside equals angle, root opening. Look for supplementary symbols, circle, weld all around, flag, field weld. Contour and finish, flat, convex, concave lines. GMC for grinding, machining, chipping. Walk through these steps every time. It's a systematic process. No magic, just logic. Practice, and you'll read symbols as easily as text. Confidence comes from repetition. You've got this. We've unlocked the language of welding symbols, from reference lines to finish details. These aren't just squiggles, they're your guide to building strong, reliable things. Understanding them empowers both designers and builders to work together seamlessly. Next time you see a drawing, lean in and decode the symbols. Practice makes it second nature. Soon, you'll visualize the entire fabrication process from a single symbol. This is true mastery, turning drawings into reality. Communication, collaboration, and building cool stuff. That's what it's all about. These symbols are elegant solutions to complex problems. You now have the key to a deeper understanding of every project. So, go forth, be curious, and keep building. The world is held together by welds, and now you speak their language. Go build something amazing.